Okay, so in this video, we are going to solve an exponential equation in which the bases are not related. Take note that whenever we solve an exponential equation, the typical approach is to check, we need to check the base of one side and the base of the other side. In some cases, the bases are already the same. In other cases, you have to convert one number so that the base will be the same. And the last type that is not common is when the base are totally not related. For instance, we cannot change 8 into base 3, so 8 and 3 are not related. So how then can we solve an exponential equation like this? So we will be using the concept from logarithmic functions, the properties of logarithmic functions, and that is on the power rule. Okay, and I'll show that here in this particular example. Okay, so when we solve for this, what we will do is we need to bring down those exponents. And the only way that we can bring down those exponents is when we introduce logarithms. Okay, so to proceed, since these two are equal, whatever we do on one side, if we do it on the other side, then that's perfectly fine. Okay, so what I will do is I will take the ln of 8 to the x plus 2 and will also take the ln of 3 to the x. Taking the ln on both sides is okay. Now, you can also use log of base 10 or any other base. So this will be x plus 2 equal to log base 10 of 3 to the x. Okay, so either way will work. So for this example, let's use the ln. So when we use the ln, then that's the time that we can apply the power rule. The power rule allows us to bring down the exponent of a given expression when it is under ln. So the left side will have x plus 2 ln of 8. See how the x plus 2 was moved in front of ln because of the power rule. So in the same way, the x on the 3 raised to x will also be moved down and placed before the ln, and then we have 3. Okay, now in concept, this ln 8 and ln 3 are numbers. So if we are solving for x, then we have to isolate the x and we have to move all the numbers or the constant on one side. Okay, so that will be our goal. But take note as well that you have x plus 2 multiplied to ln 8. So before we isolate any x, it is best to distribute the ln 8. So this becomes x times that of ln 8 plus 2 ln 8 is equal to x ln 3. And focus on the terms that contain an x. You need to place them on one side. Now, when placing them on one side, one tip is to keep most of the expressions positive. So I have the option to move x ln 3 on the left side and 2 ln 8 on the right side, but that will make my 2 ln 8 negative. So what I will do is I'll set my 2 ln 8 on the left side and have this x ln 8 be moved to the right side. So x ln 3, which is here already, minus x ln of 8. And then, once you have grouped all the terms with x, you can now factor out that x and leaving ln 3 minus ln 8 inside the parentheses. And we're almost at our goal, and that is finding x. So the last step will be to divide both sides by the group. So it's not one by one, but by the group. ln 3 minus ln 8. So that's ln 3 minus ln 8. And then we can now cancel the ln 3 minus ln 8 on this side. Therefore, our x is equal to, so x is equal to 2 ln 8 over ln 3 minus ln 8. To find this value, you can now use your calculator to compute. So simply input 2 ln 8 over ln 3 minus ln 8, and it will give you the value. Okay, so at this point, it is now needed to use, or it is now necessary to use your calculator. Okay, so I'll leave that to you. Just put it in the calculator properly by using the fraction function in the calculator. You put the 2 ln 8 over, so below here you have two values. You put ln 3 minus ln 8, and that will give you the final answer. And that's not difficult to do. Okay, so to review the steps, we started with inspecting the given exponential equation. Again, the usual exponential equation is that the bases are related or the bases are the same. However, in this case, 8 and 3 are not related. So what we did was, we took the ln of both sides so that we can apply the power rule. Now, taking ln or taking the log can be your options. In this example, we use the ln for simplicity. And then, when there are expressions to be distributed, you may distribute and simplify by grouping all the terms with x. Finally, factoring out the x will give you a group of expression that eventually will be divided or will be used as divisors of both sides until you find the x. Okay, so that's it.